This is the fourth recording of Kubernetes deep dive series, and today we are going to discuss about a tool, very important tool about the security of the DevOps infrastructure. So its name is Trivy. So Trivy focuses on scanning container images, OS packages, open source dependencies, infrastructure as code, and Kubernetes configurations for vulnerabilities, misconfiguration, and secrets. So uh, Trivy cannot scan the bugs in your code written by the developer of any language. For that, we will use the Sonar Cube. But Trivy scope is limited to vulnerabilities to, you can say, the OS level or images or infrastructure as a code, and the manifest we are writing, Docker files we are writing to deploy our containers and pods. So its complete documentation is given in this link. So I open this link here. So this is the Aka security github.io, and Trivy right now its version is 0.55, and getting started on the installation link, if you click, so you can find the installation method, either you want to install on which flavor of Linux, CentOS or Ubuntu or Debian based, or so these are all the documentation given. So I will also put some installation method in the description of this video. And if we go to the documentation, we can see what is the scope of this tool Trivy. So our target is to understand the container images scanning, file system, the operating system level scanning. If you put some images or some manifest or Docker files in your code repository, then it can scan from there. It can scan your virtual machine images. It can scan your whole Kubernetes cluster. It can scan your AWS infrastructure, and it can create the software bill of material (SBOM), and vulnerabilities, misconfiguration, and licenses information, secrets, whatever is available. So let me start with the installation. So I am running right now a machine. It's Ubuntu 22.04, and I install the Trivy tool by using the documentation I showed you. If I show you the version of the Trivy I installed, so right now I have 0.55.2, and Trivy, whenever you are going to scan uh, your anything that whatever I defined, so it will pull down the database from the CIS benchmark. So what is CIS benchmark? Let me show you. This is the Center of Internet Security. So this organization is basically managing all the vulnerabilities reported across over the internet for 25 plus vendors, uh, and all the known vulnerabilities means CVEs, common vulnerabilities, uh, are reported by CIS's benchmark, and you can say it is a database of all the known vulnerabilities and their remedies and their workaround. So you can download the benchmark related to any product, just like I can show you Alibaba Cloud, Linux, different flavor of Linux, Apache Cassandra, Tomcat. So these are all the vendors, Docker, F5, Fortinet, that and its database of CVEs are updated here. So you click anyone and you can download its PDF related to whatever vulnerabilities so far discovered in Docker and what are the remedies. So uh, we have to understand how Trivy is actually working with CIS benchmark. So Trivy, you can say, is just like a tool that is front facing the CIS benchmark, and it is using the database from the CIS benchmark. You can see its database last time when I used it is updated, and one next auto update will happen, and so everything is given here. So whatever I will scan first, it will pull down the latest database from the internet from CIS benchmark. Okay, so let's start our very first scanning, and you can see first of all I ran the Trivy variant. So if I have Docker, let me show you some images I have. Uh, okay, this is an application that I am working on some project nowadays. So I create this image. So let's scan this image and by Trivy. So we can use the command Trivy image and the name of the image. It's not mandatory that Docker is available on your machine and images are available on your machine. You can directly provide the name of the image, the repository name of the image, and it can directly scan uh, all the layers of the image available online on Docker Hub or whatever the repository you are using, registry you are using to save your images. Obviously, if you are using some secure registry, then you must have to log into that registry to scan the images. So right now I have this image. I built this image locally. I upload this image in Docker Hub. So it will scan from locally available image. So now what happened? Let me show you some. Let me scroll up. So it generate all the vulnerabilities generated by available in this image. It is a complete database. So you can see here need to update DB. It update the latest vulnerabilities, CVEs, common vulnerabilities and exposure database, and then scanning is enabled, secret scanning is enabled, and it is giving you some recommendation that we can use scanner only vulnerabilities, scan only vulnerabilities, disable secret scanning. So this will make it more faster. So here it discovered that on in this image is based on Alpine variant 3.12.1 and OS variant is this, repository is this, number of packages installed in this image, and number of language specific files. Mean uh, any binary that is not related to any package uh, or any specific binary that is available to compile any specific uh, software is not available. I will give you another example, then you can better understand. So here you can see a total unknown 0, low 11, medium 33, high 57, and critical 7 uh, vulnerabilities are found. So its table is not good. Let me just rescan it with some, then it will show me because I reduce the size of font. So now it's quite better. So here is the complete report about this image, and here you can see which library APK tools is installed, and this library is creating these two common vulnerabilities and exposure database, and its CVE's number is uh, 2021 in this year, and this serial number is provided. So it's critical, and from this library This vulnerability is also reported, it's high, and means so far these vulnerabilities are fixed. Right now of this tool, this variant is installed, and fixed variant is this one. So we are using some older variant, so we have to upgrade our to fix this vulnerability, reported vulnerability. And this one we must have to upgrade either 6 to fix this or 7 to fix this. So obviously 7 will also fix the this one. So similarly, there are this busy box, this package library is contain all these vulnerabilities, and here you can see what issue this will actually create. So this library, this package is actually creating this library libfetch, and out of memory read while libfetch user to parse. So this library has some issue that memory leak is happening in this one. So here Alpine Linux, I am using Alpine Linux in this image, and tarball parser allow a buffer. So these are some reported issues by this one. So just like busy box, invalid free or segmentation fault via malformed gzip data. So if you want to go to the detail of this CVE reported, so you can directly just copy the link of this report and you can open this. So ecosecurity.com, it has a database of all the common vulnerabilities and exposures. You can also see these the list of these values from by downloading the PDF from CIS, Common Internet Security. So this CVE, you can see the detail is given, libfetch before 2021 as used an APK tool, and this is creating some issue. It is reported here, it is mentioned here. What weakness it is creating, and affected software free on FreeBSD, it is affected, and what mitigation you can do uh, to fix this issue, and related articles are given about this everything, and its critical is 9.1. It's mean the image that I used having serious outdated libraries that can be uh, not secure to run the application on this image. So similarly, busybox, you can see all the CVEs, you can just copy these links and you can see all the details. Similarly, curl is outdated variant, and I am using, I think the newer variant or R0 is better than this newer variant. It is recommending to use this variant. So R2, R3 is recommended. So these are all the, so this is a complete list, you can see libcurl. So you should know, and the level of criticality is also mentioned here, the medium, high, critical. Okay, so now how we can fix it? uh, right now the image that I am using is this one. So let me just try to create a directory here, just like BMS app uh, image build. I'm creating a directory, and here I will create a Docker file, and you know in the Docker file we have to write from and the name of the image, and we can run a command. It's Alpine, so we can use upgrade apk upgrade command to upgrade this image. Whatever images are packages are installed, it will be upgrade. I believe apk has upgrade command. So let me just quickly build. I can say bms app, and this is the name of my repository, and I can say this updated, or I can do a tag as updated. Uh, okay, so actually, yeah, this command ran, and this Docker images, and here the new image is available. Now let me scan this again. Trivy image, using this image. Yes, this time you can see this updated image. All the packages are updated and all the vulnerabilities are gone. So this is not as much easier as I show you. Sometimes it's quite difficult. Just like let me see. Let me just scan another image. Trivy. I can scan the image of, for example, MariaDB. Okay, so let's see how much vulnerabilities are reported in the MariaDB. So a long list is available. So let me just show you the low 16, medium 5 are reported. So this is some library. This vulnerabilities is reported. Its criticality is low. Low you can avoid. Medium even you can avoid, but critical is nothing. So, but here you can see this table is divided into two parts. Why is this happening? And this is also important to understand, because these are the libraries installed by some package, but this library uh, is available under this location in this image, MariaDB image. So MariaDB image is using USR local bin Go binary. So Go binary is infected, and along with this Go binary, these all libraries are affected. You can see Golang, all the issues are reported here. So fixed variant, we must have to upgrade these variants to this variant to fix it. So now you got the idea how we can do this, and you can just update this image, or you can pull down the latest variant from Docker Hub. Maybe all the issue status is reported fixed. So far it is reported by the CV database that these all are fixable. So you can upgrade these variant number to make everything secure in your image. So we just did the scanning on these two images. So let me show you. So far we did the Trivy image and image name. Similarly, we can use Trivy to scan the issues in our, for example, Dockerfile. Let me again go to PMS app image build, and I create a Dockerfile here. I just create a very simple Dockerfile. Okay, so let me just add something more to show you. For example, I upgrade. Okay, I want to add something. For example, some file I want to put under the temp. I'm not going to run this Dockerfile to build an image, but I would just want to scan it. And let's see how this Dockerfile is not secure according to the Trivy database. So if I do Trivy config, Trivy config, and this config file, what I can provide, Kubernetes manifest, Linux operating system configuration file, any service configuration file, and Docker file. So far I am going to scan this Docker file. Let's see what it will report. I'm going to minimize the font size so that it will be, yeah, it's not in tabular form. So Dockerfile 27 test ran, succeed 23, failure 4, and low category 2, medium 1, and high 1. So first one is specify a tag in from statement image. Okay, what image I use, I have not provided a tag, so tag is mandatory. Okay, when using from statement, you should be specify a tag to avoid uncontrolled behavior with the image is updated. So every time it's not good to use the latest one. You must have to specify the tag. Even if you are using latest, you must have to specify. And if you want to see the more detail, you can go to this link. And on line number 1, this is reported. Next, hi, specify at least one user command in Dockerfile with non-root. Okay, so now, but image I build by default, if I am not specifying the user. So if you are not comfortable with the Dockerfile, you can go back to the Docker deep dive section. You can see how Docker is working. So there we discuss in detail how Dockerfile we can create. So the instruction user we must have to provide so that a non-root user will be responsible to run your services inside your the container. So I have not used the user, that's why it's reporting that you must have to use some user. So create some user and use that user to run the services. So otherwise the root user will be responsible, and what will happen? Running container with root user can lead to container escape situation. It is the best practice to run container as root and non-root user, which can be done by adding user statement. It is also giving you detail. And what is happening when you are running a container? So container is running, in the namespace, and uh, it's running actually all the processes on your base operating system. So when you are running a container as a root, so when you run ps command on your base operating system where your Docker is running, a container is running, so you will see the root user is running some processes that are running inside your container. So this is not a good practice. It should not be run by root. And both root user inside the container and on the OS level uh, can be a security issue. So if this container is compromised, anyone hack this container, that will be able to use the root privilege. They can install anything. So it's not better, mean it's mandatory to use every time a non-root user. So then that non-root user ID will be reflected in your base operating system when you will run ps-aux. That what process is actually, which user ID is responsible to run this process that is actually running inside your container. Then there is a low, medium is yellow color, high red color, and then is low. Consider using copy some file. Okay, I use add. There are two instructions, copy and add. So you should use the copy instead of add unless you want to extract the tar file. So add has more privileges. It can perform advanced level of actions. Copy is very simple, just it has privilege to just copy. So add, it is recommending to use copy instruction instead of add. So you can read this now. So this is the third and fourth one is add health check instruction. I have not added any health check instruction. I can add some labels. to identify what type of images and what it is doing. So there are a lot of other best practices, but bare minimum it is reported. So this is the way we scan an image, a Docker file. Now, if I have some Kubernetes manifest, then I will be able to scan. So let me first of all check here. So manifest scanning I will show you when I will uh, go to this section in Kubernetes scanning. So far I don't have any manifest. Or maybe check. No, I don't have. So I will do in the Kubernetes scanning section. Okay. Uh, the Trivy can also help you to build the software bill of material. Someone, if you want to report someone, mean how much packages are installed. So when I scanned it, report the number of packages, but what packages are installed and what are the dependencies. So uh, there is a way to generate. For example, I want to scan MariaDB image. Okay, so here I provide the format. Cyclonedx is the format. What is this Cyclonedx? We will discuss. Then the output. This file will be created. Software bill of material generated by Cyclone format. So let me, before running this command, let me show you on Trivy documentation. So if I just click on container image, you can see a lot of other examples how you can scan your images. What are other advanced level of commands you can use to scan? But I gave you the very basic idea. So if you could get the idea, conceptual are clear, then you can run these commands. Similarly, a file system we can scan. I will do this. Root file system of any operating system. If you have want to scan your operating system, so you can just provide the forward slash of any operating system of any or any container. It will scan each and every file. It will give you report. Similarly, code repository, how you can do. And if I go to virtual machine image scanning, if you have EC2 image, AMI, AWS machine images, or Amazon Elastic Block storage disk you have, you can scan it. And Trivy VM. So if you run Trivy -help, you can see how much, what is the scope of this Trivy. I mean, you can scan the config, file system, image, Kubernetes. It's a new tool. It's experimental, but it's working. Repository, rootfs. You can generate bill of material. You can scan the VM hard drives, complete images. Okay, you can scan any module plugin. Okay, and you can clean its cached file, whatever it's scanned so far. uh, so when you are running on the same image multiple time, it is reporting by cache, so you can clear the cache. So here I want to show you the SBOM. So Trivy can take the following software bill of material format in an input and scan the vulnerabilities and licenses. So CycloneDx, SPD, SPDX, uh, and SPDX JSON format. So to scan, you can use SBOM subcommand to pass path of SBOM. the input format is automatically detected. So actually this format, cyclonedx and spdx, are two formats to generate the report of your bill of material. So let me run the command. The Trivy image format, cyclonedx output, it will create, for example, I want to create for MariaDB, okay, and bill of material generated by the format underscore MariaDB image, and it will create this file output by using this format. So here it did a scan and okay, so this format is basically just creating the bill of material for software, not for the vulnerabilities. If you want to do the scanning of vulnerabilities too in this report, you want to add the vulnerabilities report too, then you must have to add this switch. So far I will just show you that it showed me that the version 24.04 ubuntu based image is this, and number of language specific file that I showed you in the first image too, that was 0, but here some directly binary file is copied without any package in this image. So let's see where is that. So SBOM JSON, and I showed you this one. When I scanned this, I showed you a specific path where Go binary was available. That's why it's showing number one. And let me just do more to this file created here. Wherever you will run this command, it will create this file. So bill of material format, specific variant, this is about timestamp, a lot of information is given. These are all the layers of this image, and these are all the layers. IDs are given. If we go down, we can see the components section. So this component section contain all these child values. So here is a name Ubuntu operating system. Type is operating system. Here type is application. This binary is available in this image. Okay. Then this is the type library. This is the library. Okay. Name of the library is add user. Okay. If we go down, and all the properties of this binary is given. License under GPL 2.0 license. So every software license, if it is licensed, its information is given. So if we go down, we can see here there is another library. Its name is apt, its variant, its license. Okay, so this is a big file. You can see only 2%. Just I scroll down. So it contain all the bill of material for the software. These are all the packages information given in the JSON format. I'm just going further page. You can see the type library supplier, this variant, this license, and how much 3 licenses are associated uh, with this library. And okay, so this is a huge list. Okay, I just want to go to the end this file. So far it is just giving the information about the installed libraries, packages, everything. here the dependencies now depends on, I mean, this operating system is based on all these packages. These are the list of the packages. Okay, let me just go down further. Okay, now each package, the dependencies of each package are also listed here. Okay, which package depends on which has main dependencies coming is a tree of the different packages. So this tree is mentioned here. And so whatever the complete inventory will it's generated, now it is a dependency list. Now at the end you can see the vulnerabilities section is empty because we have not used the switch in parallel uh, to this while scanning. So if we use this uh, parameter while scanning, scanner vulnerabilities, so it will override to the current I can say it's visual including vulnerabilities too, bill of material and vulnerabilities. So let me just run this again. So here if I do more to or do a cat, I just want to see that at the end what's new is now in this file. Okay, so here yeah, you can see CVE wet common vulnerabilities and exposure database number is mentioned associated with which package. So this is the complete list that we normally scan. The image is now in the JSON format. Okay, I just want to show you the section, the vulnerabilities section. Okay, so this is a complete list. So you can now generate these files. You can spend some time to understand the format of this file, how this is working. You can read some documentation online. I gave you the link. Uh, so this is a huge list. It will be a time-taking job. But now this file contains the list of vulnerabilities too, along with, if I just scroll up quickly, uh, so all the bill of material is also included here. Okay, so what we did now, we scan with cyclonedx format. The other one is spdx format. It will generate a report in a different format. If I just run the same command spdx. So spdx is cyclonedx is used for vulnerabilities and then bill of material too, but the spdx format is specialized for licensing information mostly. So I will create another file spdx format mariadb um, JSON. It's not a JSON format, just I want to say spdx format. And in Linux the this extension is doesn't matter. This is just for us to identify the type of the file. So okay, And now let me just do more to this file. Bill of material, you can see it's quite different. Let me just yeah. So here you can see spdx variant is mentioned, a document name it's MariaDB, Trivy variant, what Trivy variant were used, and so these are the layers. Okay, so each package information is given. Each package information is given in different format. Here you can see, but CVEs are not included. Licensing information is given. Uh, Dependency, I think it's also given, on which operating system it is available. Okay, so this is a different format and this is more readable. JSON is also readable. You need to convert that JSON. You can write some Python script to read that and generate some mm, presentable format. So this is the complete list. So let me now, so this is giving in the, again, depends on reference. So depend on reference, it is giving in the form of ID of the package. So, but cyclonedx output of dependency is more better than spdx. So both have some advantages and disadvantages. So now if I just add this scan vulnerabilities too, this can also scan the same command, and I can say underscore vul vulnerabilities report, bill of material along with vulnerability report of MariaDB image. And if I do more, so here you can see now uh, now it will give us the vulnerability report too. Let me show you some CVE example. I think it will give here. Yeah, here you can see the security advisory it is giving. This CVE security, this security reference was not available in the previous report I generated, but this one, when I add that switch of the vulnerability, it is adding here. So if I just do a grep to security only keyword on under this file, you can see all these CVs are reported. But if I do a grep on the older file to a security keyword, it does not contain any security keyword. Mean when you will add this scanner vulnerability vuln, then it will scan the vulnerabilities too. So I give you the idea of basic how you can perform different activity on the image. We ran some Dockerfile too. Now, uh, now if we uh, okay, now if we want to scan our Kubernetes cluster, how this is possible? So for that, I will click on the Kubernetes, and in the Kubernetes section, you can see Trivy K8s. So if I run Trivy K8s -help, so it will give me all the parameter I can use. Simply I can use report summary. So how it will connect with our Kubernetes cluster? First of all, where you install the Trivy, you must have the kubeconfig file of your cluster and the kubectl command. And that kubeconfig file user must have at least the read, uh, you can say RBAC rights on the resource that you are going to scan by the Trivy on the whole cluster. So this can connect. So far, this machine, I don't have any kubectl command. I don't have any uh, Kubernetes cluster connected from this machine. So I will, in the next video, I will show you how we can use Trivy to scan the whole Kubernetes cluster. It will give us the report of complete configuration issues, security related issues in the images, on the cluster level configuration. It will give us the report. Okay, so just like this is an example, I can include namespace on the kubeconfig report summary. Okay, so uh, so far we just did the scanning of image, and with the different ways we generate the reports, we investigate the reports. So we can integrate this Trivy tool in our DevSecOps CI/CD pipelines. So to scan the image of any image built for an application.